So yeah, right. I think I can give. You can hear me. So today is 21st, right? 21st. So I arranged this class for last Saturday class because I got accident. Right. I'm not gonna explain about that accident. Whatever happened was, but those exams not gonna postpone, right? So we have to work. So that's why I arranged this class anyhow. Right. So let's move to the lesson. Actually, I'm not fully recovered, right? But we have to continue these sessions, right? Otherwise, the thing I said earlier, right? Because exam, it will happen, right? The only thing they care the exam papers, right? I mean, they don't care what happened to us, right? What happened to you, right? Even you got accident, but nothing happened, right? No one give a chance. Okay, so anyway, I think to my memory I explained about composition of mixtures, right? Especially about fractions, right? I think I gave a note and we discussed about fractions, right? We discussed about fractions. So there are three type of fractions, right? Mass fraction, volume fraction, and mole fraction, right? I think I explained, right? So what will happen, right? Right. Okay. So we can take that fractions. The next step is we can take that fractions as a percentage. Okay. We can take that fractions as a percentage. So example, let's take a mixture, right? So you did these things in O levels also, right? Still O levels, but who had that memory, that much memory? Let's say you mixed 2 moles of water, right? H2O with 1 mole of, no, let's say not 1 mole, 0.5 moles of ethanol, right? Ethanol. So what kind of mixture you will get? I mean, what is the mole fraction? The total the number of, I mean, number of total moles, right? 2 moles plus 0.5 moles, right? And then if you consider the composition according to the ethanol, right? Ethanol, right? Don't worry, my voice is a little bit changed, right? Due to accident, actually, it's a little bit harder to talk. Okay. Right. Ethanol. Just ask me, right, if you can't understand. I explained these things last day. Ethanol. Then what is the composition of ethanol? 0.5 moles, right? Then total would be, I mean, the fraction 2.5, right? 0.5 over 2.5, right? This is a fraction, right? So we can take this as a percentage, right? We can take this as a percentage, so we can just make a integers 5 501, right? So if you take percentage, ethanol percentage, how to take the percentage. 105, we have to multiply it by 100%, then it's about 20%, right? So this solution contain 20% of ethanol, right? That's the way we do it, right? Simple mathematics, 20% ethanol. Okay, 20% of ethanol. Just write down before that we need to talk about little more about mole fraction, right? Because it's a little bit important in your level, right? A levels, not like in the O level, right? In A levels, mole fraction is more important because we use mole fractions everywhere, right? In every lessons, right? So I'll add little more about mole fraction, right? So first thing where we use mole fraction other than these two, mass fraction and volume fraction, right? We use it in what you call that, equilibrium, right? In 12, 13th lessons, right? And then in next lesson, your gas lesson, right? So everywhere, right? So it should be better to be familiar with this mole fraction, right? Just write down with the star, right? Write down with the star. I think I gave about mole fraction last day, the formula. Mole fraction x, mole fraction in the bracket x, right, is the ratio between the amount of moles between the amount of moles of a component. Mole fraction is the ratio between the amount of moles of a component and the total amount of moles of all the components in the mixture, right? In the mixture, right? It's not a hard thing, right? What we do, we just take all the moles, right? Simple fraction, but the important part is we are using it everywhere, right? That's why I said it's important, right? Otherwise it's not important, right? In O levels it's same as mass fraction and volume fraction, right? And so normally we use that as x, right? That's how we symbolize that x. So let's say there is a mixture, right? Let's say there is a mixture that contain compounds A, B, C, right? These are the compounds. The amounts are simple A, simple B, simple C, right? So how to get the mole fraction? Even if you have 100 components, same as this one, what do? We just take total of, the total moles, right? Moles of A plus number of moles of B plus number of moles of C, right? Over, or we can write it like this, the common way, in A, number of A, in B, in C, likewise. And if you wanna mole fraction of A, mole fraction of A, so you have to express it as XA, right? You have to express it as XA, okay? If you say B, then it's XB, right? That's the way we express that, okay? If you say XC, it's XC, right? The mole fraction of C, right? Then number of moles of A, that's it, right? You have to do the same thing for B, C, right? So if you like to write B, so just be familiar with this mole fraction, right? Don't get confused. It's very useful, right? So in B, in A plus in B plus in C, right? Number of moles of A, number of moles of B, number of moles of C, right? Same as C, right? Okay, just copy this. Right. This, right? Just no need to draw this one. Just copy this one, and then move to fractions. Percentage, right? Percentages of fractions, right? Just copy this one. Right. Okay. Just finish this, right? Simple equation, right? If you have 100 components, then you have to add 100 components. That's it. During the questions, normally we use, normally 3-4 components. That's it, right? No more than that. This is very important when we consider the components, right? Those are in gas state, right? When components are in gas state, this is the easiest way to express their compositions, right? Compositions of the gases, right? Gaseous mixtures, okay? That's why in the next lesson, it's very useful, right? Even in the equilibrium lesson, right? It's important. Okay. Right. Then we have to talk about, right? I already talked about that percentage. So actually, still it's a little bit harder to wipe out, right? So I don't want to take the time for explain about the accident, right? But so just copy this one. I will try to finish this part and then I will stop. Right. Right. Okay. Then write down percentage compositions. Right. Write down percentage compositions and then show this example. Right. This small topic percentage compositions. Right. Percentage compositions and then copy this example and then this is actually mole percentage, right? I mean mole. Mole percentage, right? Not the volume, not the mass, right? Each one has different percentages, right? So stick to exact composition that we consider in the question or the situation, right? Okay, enough, right? I think we finish. Just write down and then I'll write the equations. Same equation, mass percentage. Bracket WW. Same equation, mass of solute divide by, so I'll short it, mass of solution multiply by 100%, right? And then volume percentage volume percentage volume of the solute, right? Volume of the solute and then volume of the solvent. Just make it it's hard to write same thing. And then assume mole percentage, right? Moles of solute total number of moles, total moles in solute. In solute multiply by, right, just copy this one, then it's over, right? Actually I didn't remember last day whether I did or not, right? So just check the video. Even I mean I didn't remember, so I just start here.
Finish.
Right. Then next part. What did you remember about? Right. What did you remember about PPB, PPM,
Parts per million.
parts
Parts
per
per minute.
billion? Yeah, short forms, right? Uh, so when we talk about these things, right, we should have an idea where we use those parts, right? Uh, right. I mean, normally we use that expressions, right? ppm, ppb like things to express the components in the mixture, right? The composition, when those compounds present in very small amounts in the mixture, right? So let's say example, right? So actually it's a kind of a uh, mutated thing of the percentages, right? I mean 100%, right? So we can say the previous example, right? It contained 20% of alcohol, right? 20% of alcohol, right? So what is the meaning of that? If you divide the mixture into 100 pieces, right? So take the mixture, you take the mixture and you divided it into 100 pieces, right? I can't even make 100 pieces anyway. Think there's 100 pieces. So how many alcohol parts? 20, right? 20. So normally that kind of situations, right? Which method is easy? Percentage, right? I mean 100%, right? That kind of situation. But just think something like some heavy metals, right? Heavy metals, heavy metal content in some polluted water, right? This is practical thing, right? So normally that kind of situations we have to talk. We can't. Can we do using? I mean, can we present the compositions using percentage? I mean, 100%. No, we can't, right? If you use that, you have to give the values like 0.0001% or something, right? Clear? You can use it, but not practical, right? So then we have ppm, ppb, right? So same thing. So let's say if you have something, you have this percentage, right? So if you take 100, it's contained. So let's say heavy metal, right? Some kind of heavy metal, right? Cadmium percentage in polluted water. Example, right? Cadmium percentage in polluted water. You know cadmium, right? CD. Cadmium in polluted water, right? 0.00, right? So this number, right? 100. So it's hard to express using this one, right? But as a percentage, right? You have, I mean, it's hard. Even for me, it's hard. I mean, I'm lazy. I'm lazy to read it, right? 0.00 blah blah blah. So then we have ppm. Then what we do? We can we can say like this. If 0.0001% in 100, how many will be present in 1 million? 10 to the power 6,
6.
right? So then let's take convert this into powers, right? 1, 2, 3, 4, 5, right? 5 minus 5. 5 10 to the power minus 5. Okay, like this. Then what? Then BB දාමුනේ parts per billion. 9. Right, okay, now it's okay. Then get the value, right? So here we just talk about if 10 to the power minus 5% in 100, how many will be present in 1
10 to the power
1 billion, right? Yeah, 10 to the power 9 billion, right? Uh, take the value, cut this 7, then
to the power 2.
yeah, 2 ne? 10 to the power 2 ppb, right? How much easy, right? Then you can say 100 ppb, right? Easy, 100 ppb, right? So this is a unit, this is the expression we use in normally to express heavy metal content in soil sample. Heavy metals in heavy metal ඔක්කොම වගේ යන්නේ ppb ppm, right? If it's present in 100%, I mean we already die, right? We already die. I mean even it's not present in ppm level, right? Most of the time it goes to ppb level, right? The normal right, consumable things, right? You know that because I'm talking about heavy metal, that's the common thing, right? And we can say some kind of pesticides, right? Some toxic compounds, right? And some kind of gas present in atmosphere, right? Some kind of carbon particles present in atmosphere, that kind of things, right? We can go to ppm level, right? We can express those things using ppm level. You know that those fairness creams, right? I mean the things like that said, I mean, who sell that Samai, right? I mean these days it's a news, right? You know, do you know the news? I mean I saw it. I mean this is not a gossip class, but I mean she's a first class entrepreneur, right? I mean she said she took it uh, from the Colombo Fort Market payment. I mean, two 2,000 or 3,000 and sell it to 30,000 or 25,000. Right? This is my business, right? That kind of thing, right? I mean, as a girl, I mean, she has something to take, right? I mean, she's in next level in that part, right? I mean, that entrepreneur side. I mean, don't take anything other than that, right? Don't take anything, just take that marketing part. That's it, right? Then, what did I gonna say? That fair, I mean, that what you call that fairness scheme, right? Those fairness scheme, most of the time, I mean, you know, the things that working, right? I mean, you apply, then you become white, right? So, do you know how it's work actually, right? Because the way it's work, most of the time those whitening creams contain mercury, right? Okay, anyway, it's never happened, huh? Right, move to the part. Okay, just write down, right? Just write down point. When the mass of the solute, 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 when the mass of the solute is very small, is very small, is very small, very small compared to the mass of the solution. Compared to the mass of the solution. Mass of the solution. Mass of the solution. Mass of the solution. Composition can be expressed. Composition can be expressed as follows. Composition can be expressed as follows. Okay, just write down. Let's do some questions after doing all the theory parts. Otherwise, we are stuck. If I start with the questions in the middle, right? So first one, PPT, parts of trillion. Right? Sorry, not trillion. This is normal percentage. Yeah? Mass of solute.
So should I make right?
Yeah, do start to write. Yeah,
Okay.
start to copy this one. Then it's okay. Mass of solution. Multiply by 10 to the power 3. Oh. Right? Okay, just write down and just.
Sir, I can't see what you
Red color one. Okay, okay. Wait. How about now? Still.
now. Yeah, look, now.
Okay. Yeah, it's okay now, right? Just listen while you write. So this is a common way, right? And this is a normal way, right? We can express as a percentage, okay? Or we can express 100%, right? 100% using these units, right? As a unit. So how to use that? So the idea of this unit is like you have to take the solute. Not solute. Solution, right? You have to take the mass of the solution as a kilogram, right? Kilogram, and you have to take the mass of solute as a gram, right? Understood? So solution. I'll explain it. How to use it. Solution. This is very useful part. Very useful in the exam. Solution is grams solute. Right. Let's say you have a mixture that's composition is the mass composition, right? Here we just talk about mass composition, right? So mass composition is 20%, right? Right. You can say it exactly like if you take 1 kilogram of solution, right? You can say it's like this 20 grams per kilogram, right? Again 20 milligrams per gram, right? You know the relation between gram and kilogram? 10 to the power 3. This one, milligram to gram, again 10 to the power 3. Right? So here the basic idea is if you take 1 kilogram of the mixture, right, you have 20 gram of solute in the 1 kilogram of solution, right? if you get 1 gram of solution, how many solute you have? 20
20 milligram.
milligram, right? That's the idea. So in the exam, sometimes we have to use this, right? I mean, it's like a shortcut most of the time because they expecting from us, right, to shift it, right? Just that's the way we express it, right? They can give exactly like this, then we know if we get this much, then we have this much, right? Okay. Next one, ppm.
So no need to draw the.
No. I just want to
Okay.
show you. I mean,
Okay.
you can understand it. It's simple. If you like, draw it somewhere. I mean, no need. I think. Solute. So the solute mass of the solute, just write the same thing, no? Mass of the solution, no? Solution. Write the long form, right. Then you have to multiply it by 10 to the power 6. Okay, then look at the unit we can use here. Oh. Milligrams per kilogram. We have to memorize. I mean, when we do some questions, it will in your mind, but you should know.
Okay, sir.
නැත්තම් අර සමහර questions තියෙනවා අර කියන්නේ මේ හදාගන්නේ කොහොමද කියලා හිතාගන්න බෑ මේ වගේ පොඩි ස්ටෙප් එකක් තියෙන සමහරලාට මිස් වෙලා තියෙනවා. right? ඒ කියන්නේ අර කමතකයි මේක මෙහෙමත් හිතුව හැකිනේ කියන එක හිතන්න කියන්නේ. එක එක විදිහට හිතන්න එපා. ඒතර නිකන් 3D වගේ හිතන knowledge එක තියෙන්න ඕනේ. Kilograms. Number of milligrams present in kilogram or microgram in 1 gram. Amount of microgram in 1 gram, right? Amount of milligrams in kilogram, right?
So for microgram, we put capital M.
For microgram,
We put capital M or simple.
Micro. So this one micro, this is milli.
Okay.
Did I confuse that? This is milli, yeah? This is milli. This is micro.
Okay.
Right now, I mean, you already know the difference between kilogram and milligram, 10 to the power 6, right? 10 to the power 6. And another thing in this ppm, just give me a second, just write down it. Right. Yeah. So there is a small part, right, into this part in your level, right? So if you consider, right, if you consider this like you know normally these ppm, ppt, parts per thousand, right, parts per million, parts per billion, right, all the things works as a mass percentages, right? Okay, that's the basic theory in university. If you change it, you will lose marks, right? This is not the university, right? So therefore, listen. So we can frame this one, right? We can frame this unit if it's in certain temperature, right? Room temperature. Right. Likewise, we can give some frame, right? We can give some boundaries. So then, giving some boundaries, we can make something like this. Let's say you have a solution 1 liter or 1 decimeter, right? 1 decimeter, 1 cubic decimeter or 1 liter, right? So in certain temperatures, right, I mean standard temperatures, what is the mass of this 1 cubic decimeter? It would be 1 kilogram, right? So using this one, this relation, we can again write something like this. So if you have a liquid mixture, right? So normally in errors we use this. If you have a 1 liter mixture, you can express your composition even if your දැන් මේක හරියටම ගන්නවා නම් මේ මික්ස් එක තියෙන්න ඕනේ certain temperatures, right? Temperature, certain temperature එහෙම තියෙනවා, right? Condition, there are some conditions. So let's say you have that condition, you can write something like this: milligrams, the number of milligrams in 1 cubic decimeter, right? This one also valid, right, under some conditions, right? But this is not a standard one, but in exam we have to use this, right? Clear? Exam එකේදී use කරන්න වෙනවා, but not මේක අර කැතයි, because here we based on masses, because mass never change according to temperature, whatever happen, right? Even with the gravity, even if we change the gravity, mass doesn't change, right? But volume is changed. That's why we can't I mean normally we don't use volumes, right? But under some conditions we can use milligrams per cubic decimeter as a ppm. This is very important when you are deal with concentrations, right? When you have to calculate concentrations, and if they gave the value in ppm, then you can directly jump into this unit, right? Then you have cubic decimeters, right? The milligrams in 1 cubic decimeter. Then the only thing you have to do, convert this milligram into moles. Then you have a concentration. I will explain when you go to concentrations, right? Concentration දන්නවනේ කරන්න නැතිනේ, right? That's the important part of this one, right? මේක useful වෙන්නේ එහෙමයි. දැන් but then in the liquid mixture, while to converting this kind of unit, I mean you can't do anything. I mean මේක කරාගේ ලොකුවට මොකුත් කරන්න බැරි වෙයි. But this one it's easy, right? That's the important part. We never use this one in universities, right? This is not university. මේක අර හරියටම හරි නෑ, හැබැයි valid in A levels. මේක ඕන වෙනවා එකක් දාගන්න, right? Then ppb, mass of the solute, mass of solvent, solvent, then multiply by 10 to the power 9. Right. Right. ppb. The common used one is ppm, right? In ALS, most of the time they questioning about ppm, but that means they doesn't ask ppm නෙවෙයි, right? එහෙම නෙමෙයි ඒක අහනවා, but most of the time they questioning ppm. Right. Micrograms per kilogram. And you can use this one also, micrograms in micrograms in 1 cubic decimeter. Dua today is little bit slow, right? I mean,
Okay.
මම අර normal තත්ත්වයේ නෙමෙයි ඉන්න හින්දා sorry යා. මට හරි අවුල් ඇත්තටම ක්ලාස් එකක් ඔය එහෙම දැන් අර කලින් දවස් ගත්තර මේ අකුණු ගහන්න තරම් වුණා මේ right. right. මේක දුව volume fractions විදිහටත් යන්න පුළුවන් ඕක. එතෙන්දි volume fractions විදිහට ගියොත් මේ ආයේ ලියන්න ඕනෙත් නෑ මේකේ මේ මම මෙතෙන්නම ලියන්නද volume fractions විදිහට යන එක මේ මේ පොඩි sentence මේ ටික finish කරගන්න right. කෙටියෙන් දාගමුකෝ. Write down. Same theory can be applied to volume fraction. 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 Though when do you have exams?
Next week starting.
Next week is what are the lessons now they cover?
Until 4th lesson.
Until fourth one. Did they finish fourth one or in the middle of the fourth one?
In the middle of the.
Middle of the okay. Right. Same theory can be applied to volume fraction. You can write PPT, right? If you take PPT as a volume fraction, right? You can write it like mL minus 1, right? Liters per milliliters, ppm microliter per liter, right? Liters or decimeters, right? You know both are same, right? You can change it. ppb nl minus 1. Nanoliter. You know 10 to the power minus 9, right? 10 to the power minus 9. Right. Okay, just write down example. NaCl mixture with NaCl mixture with NaCl mixture with composition 10 ppm 10 10 ppm 10 ppm NaCl 10 ppm NaCl means 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 if we divide our mixture if we divide our mixture if we divide our mixture into million parts if we divide our mixture into million parts we divide our mixture into million parts we divide our mixture into million parts 10 parts 10 parts are NaCl 10 parts are NaCl 10 parts are NaCl. Just write down 10 ppm means 10 milligrams per 1 kilogram, right? 1 kg solution contain 1 kg solution contain 10 milligrams of NaCl.
Okay, sir.
Right. Okay, write down this small question, small one. NaOH solution NaOH solution was prepared NaOH solution was by 10 milligrams of NaOH and 10 milligrams of NaOH and 10 milligrams of NaOH and 990 grams of water. 990 grams of water. 990 grams of water. Find the NaOH composition. Find the NaOH composition in ppm. Find the NaOH composition in ppm.
So 1.1 ppm.
1 point.
One.
Yeah, 1.1. Correct. Right. No need to write it. Right. Simple. Right. Next one. Right. Okay. Now important part. Write down the topic. Concentrations of solution. Concentrations of solution. In the bracket, molarity. Right. Okay. What is concentration? Concentration means, yeah, it's another way of expression, right? Another way to express composition, right? Importance of the significance of this concentration term and molarity, right? In chemistry and in science, that's the way we use everywhere, right? That's the most way we use to express compositions, right? Other than all that ppb, ppm, like right? The most used one, the most used way to express composition is concentration, right? So actually everywhere, right, we use this one. Chemistry mainly based on concentrations, right? So concentration means simply same as previous expressions. Here we express our composition according to the volume of the solution and the number of moles of solute. Okay, volume of the solution,
Number of moles.
number of moles of solute, right? Number of moles of solute. Okay, that's the way we express it. Okay, so simply we can say this amount of volume contain this much moles, right? So if you say this is 1 decimeter, right? 1 cubic decimeter volume, right? It's contained 5 moles of solute, right? So we can say concentration here is, concentration is
Number of moles divided by.
yeah, number of moles divided by volume, 5 over 1, right? 5 moles per cubic decimeters. The difference of previous expressions, generally they don't have any units, right? We give some units, but normally they don't have units because that units cut off, right? Cut වෙනවනේ, right? But here concentration or molarity have unit, right? That's the important part. Okay, just write down the point. Just write down concentration of a solution. Concentration of a solution is the amount of solute. Is the amount of solute. Is the amount of solute the amount of solute present in a given amount of solvent, given amount of solvent or given amount of solution, given amount of solvent or a given amount of solution. Am I fast? No, right? Finish.
Yes, sir.
All right. Given amount of solution. It is also known as molarity. It is also known as. It is also known as. It is also known as molarity. Okay. In the bracket, capital lemma, molarity. Right? You know, normally standard solutions, right? Do you know standard solutions that we made in O-levels, right? O-level standard solutions, right? Normally in the lab, right? Laboratories, standard solutions name like 1M solution, right? See, right? 2M solution. Haven't you seen that? Right? 2M solution, 1M solution, 0.5M solution. That's the way we express it in the laboratory. That's it. Molarity. Concentration. Right? Same concentration. Right? But it has a special unit, right? Decimeters per cubic decimeters per
No.
mole. Sorry,
Moles per
mole
cubic.
mole per cubic decimeters, right? Sorry, yeah, pathetic. Right. Just write down the equation. Molarity. Moles of solute. Get simple in decimeters. Do a here I am expressing molarity, right? So when we consider about molarity, the units should be decimeters. I mean, the top one moles and the bottom one decimeters or liters, right? So if you talk about concentration, exactly concentration, I mean, you can use whatever the units, right? But generally, we using this one, right? Molarity and concentration, both similar because we use the same thing, but get the idea, right? Then you might confuse why do we use exactly this one for molarity, right? Because molarity has a special units, right? Concentration doesn't, right? Concentration doesn't. It has a SI unit, right? Moles per cubic meters, but we don't use it generally, right? Normally concentration also use the unit of molarity. Same thing, difference is units. Right. That's the reason, molarity. Decimeters. Here all liters. You can write liters. But in our syllabus, our syllabus generally we use decimeters. Everywhere we using decimeters, but leaders are correct. Leaders are correct. If you are lazy to write two letters and -3, then write to L -1, right? It's a bit easy, but stick to decimeters, it's easy. Like common එක කරන්න ඒක practice කරන්න. But if you use leaders, it's correct. Leaders. ඔය සමහර චූටි තැන් තියෙනවා ඒවා මේ හරියටම දැනගත්තාම ඉවරයි නැත්නම් අර චූටි ඕන වෙන්නෙත් නැහැ ඉතින් හරියටම හරියනේ එතකොට දැනගත්තා. Right. Let me show some small animation. Give me a second. පොඩි ළමයින්ගේ animations මේවා මේ අර O level ළමයින් නම් හොඳයි කමන්නේ. Right. නිකන් බලා ගන්න, right? So here can you see the arrowhead and those things?
Yes, sir.
Okay. Here we have a solution, right? We have a solution and we can add our solutes, right? So it might be a yeah, we can choose drink mix, copper sulfate. Okay, let's say copper sulfate, blue color one. Okay, let's say let's take potassium permanganate. Okay, then we can change the volume of the solution, right? We can change the volume of solution and we can remove the solution. We can evaporate also, right? Let's see what will happen when we add some solid and those things. We can check the concentration, right? So it shows in this phase, right? So then I'll add okay, it's suddenly increasing. Saturated, okay. See what will happen after saturation, right? After adding, it's filled in the bottom, right? How much I add? So this is the maximum concentration, right? The maximum number of moles this solution can hold, right? You know, I think you know. Did you remember saturated solution?
Yes, sir.
Right. So after saturation, it's not dissolved, right? So let's take different copper sulfate. Okay. Let's see what happened. So it dissolved more than permanganate. So the concentration is increasing, and so when we increase the volume, then see again concentration is decreasing, right? Concentration is decreasing. So then we can evaporate also. Let's see what happens when it evaporates. See, then again concentration is increasing. Why? The amount of solvent is decreasing. Due to that, concentration is increasing, right? Solution getting concentrated, right? It increasing. See, it gets saturated. 1.3 moles per liter, right? Normally the using of that units, right, that liters and those things depend on the country, right? Normally that right, I think that's it, right? So solution here, we can change the solution also. Change. They didn't get pin. ඒක දාන්න පුළුවන් right enough මේ පොඩි බබාලගේ මේ අර නිකන් බලන්න පෙන්නන්න පිටරටවල බබාලට එහෙම පෙන්නන්නේ ඔහොමද නෑ ලොකු අයටත් පෙන්නනවා බබාලට විතරක් නෙමෙයි right මොකද්ද මම මේ කියන්නේ කී කමද උනානේ concentration right මේක ලිව්වනේ then just write down a small question. How many grams of potassium dichromate? Write down a small question. How many grams of potassium dichromate? Potassium dichromate. Dichromate are required to prepare 250 milliliters solution with 1 mol dm-3 concentration. Molar mass of K2Cr2O3 sorry O7 is 294.9 right you know right number we want 250 ml මේ O level වල නෑ අර O level හැදුවා මේ අර K2 K2 එක විතරයි පොඩ්ඩක් අලුත් වගේ තියෙන්නේ right so මේ ගායම පොඩ්ඩ අලුතෙන් කරන්න වෙනවා මේ කරද්දි විතරයි මම ග්ලාසියස් එක්ස්ප්ලেইন කරන්න යන්නේ නැහැ මම ප්‍රැක්ටිකල්ස් කරාද ඉස්කෝලේ කරා කියලා කිව්වේ
ඔව් සර්
right ප්‍රැක්ටිකල්ස් කරේවා නම් ගමන්නේ සාමාන්‍ය නැතනම් ඔයාලා සාමාන්‍ය ප්‍රැක්ටිකල්ස් ඔක්කොම වගේ පිළිවෙලට කරනවද ඉස්කෝලේ
third lesson එකේ තමයි practicals කරන්න පටන් ගන්නේ.
second day මේ first second එකේ කරේ නැද්ද? ඒක first second එකේ ඉතින් ලොකුවටම නෑ අර මේ demonstrations තමයි ඉතින් කරන්න තියෙන්නේ. first එකේ තියෙන්නේ අර මොනවද? cathode rays උයි ඒව නෙවෙයි. කොහොම හරි ගමන්නේ මේ glasswares ගැන idea එකක් තියෙනවද නේද? මම ඒ ටික අපි මම මොකක් කරන්න මේ මෙතන we need volumetric flask right 250 right the best way to doing this kind of calculation is backward right now we just finish you already make you already made that solution. You already made it, right? Now you have a solution. How much volume? You have 250, right? And this solution, the concentration of this solution is 1 m. It's a capital M, right? 1 m. It's easy. Concentration is 1 m, right? So now you already made it. Then just calculate how many moles present here. How many moles present inside of this solution? How many moles? So what is the concentration? 1 m. 1 m means 1 moles in 1 cubic decimeter, right? But here the solution is 250, right? So if you have 1 decimeter, it's contain 1 mol. 1 decimeter means 1000 milliliters. If you have 1000 milliliters, that solution contain 1 mole, right? 1000 milliliters. If you get 1000 milliliters, this solution contain 1 mole. Then if you take 250 milliliters, how many moles contain? Clear? 1000ක් ගත්තොත් දැන් මේක මෙහෙමයි, right? දැන් O level ළමයින්ට මම කියන්නේ මෙහෙම හිතන්න කියලා. මම කෙලින්ම කියන්නේ C equals simple n divide by v. දැන් මම n එක ගත්තා. හරිද? වෙන මොකුත් මම කියන්නේ නැහැ. උන්ට කියන්න ඕනෙත් නැහැ. හරි මේක ගත්තා. එතනින් ඊළඟ ස්ටෙප් එක මේ simple n equals capital simple m divide by capital M. ඔන්න ඔතනින් හෙව්වා. මම හොයපල්ලා කියලා මම කියලා නිකන් ඉන්නවා. හරිද? ඒ කියන්නේ ඇති උන්ට වෙන මොකුත් ඕන හිතන්න දෙයක් නැහැ නේ. right? දැන් A level ළමයින්ට මේ ඔහොම සරලයි කියලා හරියන්නේ නැහැ. right? මේක සරල නෑ නෙමෙයි මේක සරලයි ඇත්තටම. මේක පොඩ්ඩක් හිතෙන්න එපා. මේකේ මෙලෝ මගුලක් දන්නේ නැති කාට තාම මෙන්න එහෙම ඉලක්ක කූ ටිකක් තියෙනවා. දැම්මා ගත්තා එච්චරයි. right? දැන් මේකෙදි පොඩ්ඩක් අර මේ හිතන්න වෙනවා. දැන් ඒ කියන්නේ එක එක විදියට අර තැන හැටියට ඇඩ්ජස්ට් කරගන්න ඕනේ. හැබැයි මේක තමයි විදිය. මේ ඒ ළමෙක් හිතන්න ඕනේ. අර c equals මේ කියලා මතක තියාගෙන හදන්නේ නැහැ. මේ c equals n divide by v ලිව්වට මාක්ස් දෙන්නෙත් නැහැ එක්සෑම් එකේ. කෙලින්ම මේ ස්ටෙප් එකට මාක් එක යන්නේ නැහැ. 3 හරි 2 හරි 5 හරි 5 ත් යනවා 3 ත් යනවා. දැන් ගාන හැටියට කෙලින්ම ඔය 1000 වලින් ඒ යන විදිහට යන්නේ. එතකොට you have to think like that. If you have 1000 milliliters, it contain 1 mol. But now we have 250. Then how many moles contain in 250 ml? Right? 4 over 1. 4 over 1 means 0.25 ml. Right? Sorry, mol. දැන් මේක ලියද්දි මේ වගේ ලියද්දි දැන් මේ මෙහෙම units දාන්න ඕනේ එකක් එහෙම දැම්ම හැකි. Or if you like, you can add final unit like this. I mean final unit is moles, right? Final unit is moles, no? Right? So then put the bracket and then add final so moles. Final unit is mole, right? නිදිමතයිද?
Yes, sir. We had
දැන් මමත් නිකන් අර අමාරුවෙන් හිමීට කරන හින්දා නිදිමතක් දන්නේ නැහැ. right? පොඩ්ඩක් ඉන්නකො ඈ. right. මේක එතකොට දැන් another thing, right? Still you can get the marks, right? Nothing happened. Still you can get the marks. You are eligible. And or you can then another thing, you have to mention it. You have to mention what you are doing. You have to say what is this number of moles. You have to mention it using sentence. whatever the sentence, it doesn't matter, right? Sentence say gamma වැඩක් නැහැ, right? එහෙනම් gammaත් හදනවා. gamma මොකද දෙයක් වැඩක් නැහැ. Just say it, what you are doing, right? So here I'm finding number of moles in the solution, final solution. Number of, if you like, just mention K2 Cr2 K2 Cr2 Cr2O7 moles, or just write K2 Cr2 moles. That's it. K2 Cr2O7 moles, that's it. Right? Then they know. Even if you didn't mention the moles, because you mention moles here, if you are lucky, they might consider it as a unit, right? If you are lucky, right? That's the way. මෙහෙම මෙතන මෙන්ෂන් කරලා තියෙන හින්දා සමහරලාට කන්සිඩර් කරනවා, right? මාක් එකක් දෙන්න, මොකද මේ ළමයා මෙතන මෙන්ෂන් කරලා තියෙනවා කියන එක එතන ගන්නවා, right? But here you have to mention here. මෙතන ස්ටෙප් එකට අවුලක් වෙන්නේ නැහැ. මෙතන ස්ටෙප් එකේදී මෙතනදී මෙන්ෂන් කරනවා, right? මේ සිම්පල් ගාන මෙහෙම ගණන් අහන්නේ නැහැ. මේ කොහොම ගණන් තියෙනවද කියන කොහොම අහන්නේ. ඔක පොඩි තැනක තියෙනවා. ඉතින් කොහොම හොයන්නේ? කන්සන්ට්‍රේෂන් එක දෙනවනේ. ටයිට්‍රේෂන් එක වගේ කරද්දි දැන් ටයිට්‍රේෂන් උත් මම කියලා දෙන්න. ටයිට්‍රේෂන් කරන්න මේ මොනවද කරලා ඉන්න බෑ මොනවද equations, formula balancing equation, right? Then we have number of moles. In this exact solution, this exact solution contain number 0.25 moles, right? Then in the laboratory, right, I always said that, can we measure moles? Is there equipment to measure moles? What we can measure? Concentration. Okay, we can calculate concentrations. What we can measure? Instrument. Which instrument? What kind of instrument we have? We can measure volumes and masses, right? That's the only thing we can measure. So normally to make standard solution, this kind of solutions, most of the time we are measuring masses. Actually, measuring mass is the what you call that, perfect way, right? Measuring mass, right? Because we have, I mean, you know that you call that chemical balance, right? I mean, there's a special kind of chemical balances we can measure even up to micro level, right? Micrograms, right? Not normal micro, I mean 0.01 micrograms, right? Depend on the instrument, right? Very sensitive instrument. Normally that kind of instrument, I mean, there's a cover around the scale, right? So we have to open the cover, and then we can add the our compound, right? Because the reason they are covered, that scales sensitive to even that air, normal wind. මෙහෙම පිම්බත් මෙහෙම ගාලා පිම්බත් ඒකේ value එකක් එනවා, right? That much sensitive. So normally that's why we measure masses, right? But measuring volume is that not that much. I can't say it's not perfect, but masses are, I mean, to measure masses, we have very special kind of instruments, right? Very sensitive instruments, right? Measuring volume is limited sometimes, okay? Right. So now we have number of volumes, right? We calculated it. So in the laboratory, we can measure masses, right? We can measure masses. We can't measure number of moles, right? We don't have a instrument to measure that. Therefore, we have to convert this number of moles into masses, right? How to convert moles into mass? How to find mass when we have moles? we can use that n equals simple m divided by v equation, right? Sorry, capital M, capital M, right? Point two, sorry, we don't know mass, right? What is the value? 294.9. Just take 295, it's enough. Just take 295. Moles 0.25, right? Using 104 might be easier for you. I don't know, right? Just find the value, then you can get the value in grams, right? Some amount of grams.
$73.75.
What is the value? Do 43 point
73.7.
73 point, let's say 73, right? Let me check. Yeah, 73.75. You are working calculator. Right. Good. Then next part is dilution of solution. Right. What happen when we dilute the solution? Okay. In the one. No. Right. Just write down the topic. Dilution of solution. Right. It's a part of concentration. Right? Dilution of solution. Right. What is this dilution? Dilution means kind of a technique that we use to make solvents, solutions using high concentrated ones, right? Using high concentrated solution, right? Concentration and low concentration. Right. We use dilution to make low concentrated solution using high concentrated one, right? Dilution means just reducing the concentration, right? Diluting, right? I mean, we know that, right? I mean, so that the most common dilution in our society, what kind of dilution? Adding soda or something into soda or water into, yeah, alcohol, right? Right. So that's the most common dilution, right? Adding, I mean, I know you don't know about this, right? Even I don't know, but that's the common dilution, right? Most common dilution, adding soda or water into, or any kind of juice into alcohol, right? then what happened? It's getting diluted. Simply we call it sandy or something, right? Sandy, yeah, sandy or something. Sandy karna what anything, and I don't know, right? Technical term is dilution, right? So what happened after dilute? You can drink it, right? That means that it's strong, right? That strongness is reduced, right? In chemically, the amount of ethanol in the volume, right? In the beginning, let's say right, after dilution, දැන් එහෙම ඩයිලූට් කරන්නේ නැතුව මොන කට්ටියක් ඉන්නවා ඉතින් ඈ. හරිද සමහර සීයලා ඉන්නේ එළින්ම වෙන්නේ. දැකලා තියෙනවද මේ දැකලා කියන්නේ ඇත්තට දකින්නේ මම ඇත්තට දැකලත් නැහැ. ඔය මේ බාර් එකට යනවා. බාර් එකට ගිහිල්ලා ගෙලින්ම ඉල්ල ගන්නවා. මේව කඩනවා. දැන් මේව කරනවා. ඉස් බෝතලේ දෙනවා යනවා. කිසි කරදරයක් නැහැ කාටවත්. අය තැන් තැන් වල බෝතල් දාන්න යනම්මන්නේ නැහැ. එළින්ම ගත්තා. ආයි මොන ඩයිලූට්ද? ඩයිලූට් වෙනවා ඩයිලූට් වෙන්නේ බඩේදී. හරි ඩයිලූෂන් එක බඩේදී වෙන්නේ. Right. Then so this one has higher volume, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So this one has higher concentration, this one has lower concentration, right? So after dilution, this thing happen, right? The number of moles in the volume is reduced, right? Because here the same number of volumes in low volume, right? Here same number of moles in low volume. Let me show it. Here N is higher, V is lower. This one V is higher, N is lower, right? Moles. Sorry. මේ moles ගාන අඩු වෙලා නැහැ, moles ගාන same නේ. මේ අර opinion volume එක තියෙන moles ගාන change වෙන්නේ moles ගාන එකයි. Okay, anyway, that's the idea, right? Dilution. Write down a small sentence. Topic dilution of solution. Write down a point. Dilution is the procedure. Dilution is the procedure. Dilution is the procedure. Dilution is the procedure. Dilution is the procedure for preparing a less concentrated solution from a more concentrated one. Right. Then just draw a simple diagram, right? If you like, just draw it, otherwise no need. Concentrated. This one diluted, nah? Right. Write down a point. In this process, in this process, in this process, in this process, we decrease the concentration. We decrease the concentration. We decrease the concentration. We decrease the concentration without changing, without changing without changing the number of moles, without changing the number of moles of solute, number of moles of number of moles of solute in the solution, right? We just take certain amount of moles, right? I'll explain it, right? Finish, ne? Right. Yeah. So let's say we are making a kind of a solution using a high concentrated one, right? Low concent dilute solution using high concentrated one, right? As I said, the number of moles, right, are equal. Here, if you say number of moles 11 moles, right? 11 moles, right? 11. Here also 11 moles, right? බෝල ගන්න එකයිනේ, right? එතකොට after you make that, the number of moles should be equal, right? Same as the initial, right? Should be, right? So what do we know? Moles of solute before dilute should be equals to moles of solute after dilute, right? That's the relation. That's the only thing that we know, right? So if we know the moles, right, you know we have a relation, right? We have relationship C equals N over V, right? So we can write it like N equals CV, right? You can write it like that. So then we can write that equation also. C equals N equals CV, right? So then this number of moles are similar, right? Therefore we can write this side. So this side මේ යටින් ලියන්න නැත්නම් මේ සයිඩ් එකෙන් දාන්න යටින් ලියුත් කතයි, right? කමකුත් නෑ කැමැත්තක් නේ. Therefore before C1 V1 should be equals after C2 V2. What is this? This is initial concentration and initial volume. Here we change the volume, right? Normally the second concentration is lower, right? Volume is higher. In this case, concentration is higher, volume is lower, right? Because the only way we are diluting, right? We can't make concentrated one using diluted one. I mean, we can, but it's not the way we prepare solutions, right? I mean, how to prepare a diluted one, sorry, concentrated one from diluted one? We have to evaporate, right? Like I did that in the simulation, right? That animation, right? We call it simulations, right? Teaching aids, whatever. ඒක එවපරේට් කරා වගේ එවපරේට් කරන්න ඕනේ. නේද? එතකොට අර මේ සැන්ඩි කරපුකෙන් කන්සන්ට්‍රේටඩ් ඇල්කොහොල් එකක් හැදුව හැකිද? එහෙම කරන්න බෑ. එහෙම කරද්දී ඇල්කොහොල් එකත් යනවා ඔක්කොටම යනවා, right? සමහර ඒවාට කර හැකිද? sugar වගේ එකකට නම් කර හැකිද? But we don't know, right? I mean, it's hard to get the concentrations, right? So no, the way we make diluted one from concentrated one, that's the way we make it, right? So therefore second concentration is lower, second volume is higher, right? We take certain amount of volume from the concentrated one, then we add it into the example like that. I just copy this one. දාගන්න. Right. දැන් නම් චුට්ටක් විතර අමාරුයි අර ඔළුව එක දිගට තියන් හිටියනේ කියන්නේ. කවන්න ඒව හිතන්න එපා. දාගන්න. ගහන් උපරිම කරලා නවත්තන්න. right හරිනේ දාගත්තනේ right මෙහෙමද මේක question එක ආවමත් මම කියලා දෙන්න the common way, right? Let's say you want to make some solution, right? So first you need a concentrated solution, right? Let's say this one has a certain amount of right, let's say 2m. You have 2m solution, right? And you're gonna make you can make whatever the solution that less than 2m, right? It should be less than 2m. It might be 1.5. You can make it, right? So then you have to, I mean, you know how much you need, the volume that you need. Then according to that, select the volumetric flask, right? Select the volumetric flask and then take certain amount. Certain amount means certain number of moles, right? How to get certain number of moles? You have to find what is the volume that contain the certain number of moles that you consider. ඔයාට ඕන moles ගාන තියෙන volume එක ඔයා ගන්න. That's the calculation, right? And then take that solution into this one. It's like number of moles. අර වැම් measure කරලා grams ගාන ගන්නවා වගේම තමයි. ඊට පස්සේ මේකට දැම්මා. ඊට පස්සේ dilute කරා. මේ sorry. Fill it up to the line. Right? එච්චර simple case එකක් තියෙනවා. question එකක් දැක් කරද්දි මේ question එකක් තියෙනවා දෙන්න. Right. Write with the star under the equation, right? So this is the equation, it's valid, right? You can use it anywhere, right? Right. To use that, so there is a small condition. These volumes, the units should be in same, sorry, the factors should be in same unit, right? You දන්නවනේ physics දන්න මට වැඩි දන්නවා units ගැන දැන්. අපි දන්නේ එච්චර physics කරා physics first lesson එක කරා කියන අපිට වැඩි දන්නවා units ගැන, right? ඒවා දන්නවා චූටි චූටි දේවල් අපිටත් ඉගෙනුවා ඒක. අපි physics කරලානේ A level වල කරන්නේ. Okay. Write this star. We should be in same unit after the equation. We should be in same unit. We should be in same unit. And write this one. C1 bigger than C2 and V2 bigger than V1. Right. Write that also.
After writing, we should be the same.
Yeah, we should
Exercise.
be same unit. Yeah, then this one, this relation. So then write down this small question. Prepare 500 ml of 500 ml of a 2m HCl solution, 2m HCl solution starting with 8m solution. Right? So in this kind of question, please, right? Right. In this kind of question, first you have to find the volume that you have to taken from the first solution, right? Or concentrated one, right? That's the part. That to find that, what you need that equation. Oh, එහෙම equation එකක් කියලා ඕනෙත් නැහැ. ඉතින් ඒක දිගට හදලා හොයා ගන්නත් පුළුවන් ඈ. එහෙම equation එකක්ම මේ තියනවා ඒකම දාන්න ඕනේ කොහෙවත් කතාවක් නැහැ. ඒක දිගට හදනවා නම් එහෙම හදන්නත් පුළුවන්. මොකද equation එක හැදිලා තියෙන්නේ මොකක් හරි base එකක් උඩනේ, right? Equation එකේ lazy ඉතින්, right? The main part is finding that volume. After find that volume, it's easy. Add it into the volumetric flask and then finish, right? And fill it, then it's done, right? So what is the question? They gave 8m solution, right? I mean 8m, right? It doesn't have a limit, right? So let's say it's a bigger one, right? We don't need the volume of that, right? So then what we have to make, a solution that concentration is 2, right? 2m and volume is 500 ml. As I said earlier, in this kind of questions, just go backward, right? Not only this one, හැම මගුලෙන් backward තමයි lazy. හරිද? හුඟක් වෙලාවට. හරිද? හැම එකම තමයි දැන් investigation එකක් කරන්නේ backward. හරි? ඉස්සරහින් නම් කරන්නේ, right? Then just find here you don't need to find anything, right? දැන් මෙහෙම find කතාවක් මොකක්ද නැද? මේ කෙලිම data ටික තියෙනවනේ. මේක හදන්න ඕන කරන volume එක කෙලින්ම ගත්ත හැකි, right? මේක හදන්න ඕන volume එක කෙලින්ම ගත්ත හැකි අර equation එකට දාලා එහෙම ගන්නෙ නැත්තම් if you don't like to use that equation, the long method, right? දැන් මම long method එක හදන්න නැතුව ඉන්නම් මම කියන්න හදන විදිය ඕනනම් මොකද කරන්නේ? මෙතන මෝල්ස් ගාන හොයාගන්න ඕනේ. මේකේ තියෙන්නේ මම මේ දැන් දිගකම කියන්නේ. අර ඉතින් ඕන එකට දැම්මේ ඉඳන්ම කියලා තියෙන්නේ. මේකේ මෝල්ස් ගාන හොයාගන්න ඒ මෝල්ස් ගාන අරගෙන මේකෙන් හොයාගන්න ඕනේ ඒ මෝල්ස් ගාන තියෙන වොලියුම් එක. Right? Find the number of moles in this solution and then find the volume that contain your number of moles. Then you know the volume, then finish. Same thing. But it's easy for us. We know the equation C1 V1, C2 V2. What is the initial volume? Because we need same amount of moles, right? එක moles ගන්න තියෙන අපි මේකෙන් ගන්න ටිකේ තියෙන්නේ තියෙන moles ගන්න තමයි මෙතන තියෙන්නේ. අපි මේකෙන් ගත්තනේ let's say we took V1, right? We took V1. So here we're going to find V1, right? Initial concentration 8 m, doesn't matter, right? Same volume. We don't know V. C2 2m, final volume 500. It doesn't matter, right? Then you will got don't worry about m, right? Because here you might think m contain decimeters. It doesn't matter because V you will get as a milliliters, right? So it's okay. M capenometer, right? Right. 4 V1 equals 500 ml. Then divide it. 125, ne? 1.5 isn't it? 125, ne? No, 125.
Yes.
125. So V1 is 125 ml. So what is the catch? So you take 125 ml from this stock. We call it stock solution. Stock solution, and then add it into the solution. This solution, this volumetric flask, and fill it up to 500. Right? ඒ තමයි ස්ටෑන්ඩඩ් මෙතඩ් එක. මේකෙන් ඇදලා ගත්ත 125 මේකට දැම්මා. ඒක ෆිල් කරා. එච්චරයි. done. Done and dusted. එච්චරයි. ක්ලියර් නේ? මේ හදන්න නැතිනේ දන්න ලේසි. එච්චරයි. පැටලුන්නේ නැහනේ. මේ අර මෙතඩ් එක මම උනා ඊළඟ දවසේ හදන්නම් මේ දෙන්න පොඩ්ඩක් අමාරුයි දරුවෝ. මේ මම නවත්තන්නම් අදට. මොකද්ද මේ මෙතන අවුලන්නේ මෙතන නවත්තන්න පුළුවන් ඊළඟ කෑල්ල දැන් මේ බැලන්සින් තියෙන්නේ මම හෙට එඩිට් කරන්නම් ඈ. හෙට මේ බැලන්සින් ඉක්වේෂන් සෙට් එක හෙට කරමු. ඊට පස්සේ ඒ ටික කරලා ඒ කියන්නේ දැන් අර මේවා මෙහෙම තනි ක්වෙස්චන් ඒවා එක්කම කෑලි. ඒ කියන්නේ මේන් ක්වෙස්චන් එකක් ගත්තාම මේවා කෑලි වලට තමයි ඕන වෙන්නේ. දැන් MCQ වලට ආවොත් එක වෙන කතාවක්. දැන් මේක ඉන්නේ සාමාන්‍යයෙන් ඊවෙනි ක්වෙස්චන් එකේද අපේ 9 එකේ ඉන්නේ 9 නේ. ඒකේ ඔව් 9 නේ ඔව් 9th එකේ තමයි ඉන්නේ. 9th එක ඉනෝගනික් පාර්ට් එකත් එක්ක තමයි එන්නේ. කියන්නේ ඒකේ භාගයක ඒ කියන්නේ දිග කැල්කියුලේෂන් එකක්. ඒකේ ඉතින් ඒවා ස්ටෙප්ස් යන්න මේවා තමයි අර බේසික් අර ලයික් අර මොනවද මේ එකතු ගන්න අඩු කරනවා වගේ තමයි සබ්ස්ට්‍රැක්ෂන්ස් සබ්ස්ටිටියුෂන්ස් වගේ තමයි ඉතින්. හරි. මේ එහෙම නැත්නම් යන්න බෑ ඉස්සරහට. මේ රයිට්. ඒකට අපි ඒ අර තව තියටි කෙනේ අර ටයිට්‍රේෂන් සෙට් එක ආඩසේ ලොකු ටයිප් එක ගණන් ටිකක් හදමු. එතකොට මේ චුටි වලින් තේරෙනවනේ නඩ අවුලක් නැහැ නේ. මේ කරපු ටික කොහොමද? Is it clear? Right? Any problem?
Yes, clear.
Clear, right?
Yes.
Just ask me if you can't understand anything. Right? So I'll stop at here. මේ අර මිස් වෙච්ච කැලේ පොඩ්ඩක් බලන්න ඒකේ ලොකු දෙයක් නෑ. පොඩ්ඩක් බලලා දාන්න නෝට් එක.
Okay.
චූටි නෝට් එකක් දෙන්න සෙන්ටෙන්ස් එකක් දෙන්න. right? මේ ආයි මොකක් හරි වුණොත් මේ කෝල් එකක්ම ගන්න මේ කිසි ඉෂුව එකක් නෑ. right? මේ ඒ වෙලාවට විතර නෙමෙයි ඕන වෙලාවක අපි ෆෝන් ආන්සර් කරනවා කියන්නේ නිදියන වෙලාව ඇර මේ සාමාන්‍ය මිනිස්සු වැඩ කරන වෙලාවල් අපි කියන්නේ ඕන වෙලාවක ළමයි දෙයක් ඇහුවොත් අපි ෆෝන් වැඩ එහෙම බිසි ඉෂුව එකක් නෑ. අපි නිකන් අර ඇසිස්ටන්ට්ලා එහෙම කියලා එහෙම නෑ මේ අපි නිකන් අපොයින්ට්මන්ට් දාන්න ඕනේ නෑ හරි මේ right එහෙනම් හරිනේ so I'll stop that here so I'll do this remain part tomorrow right uh, if anything happen I mean anything happen means I mean nothing to be happen මොකුත් වෙන්න දෙයක් නෑ මේ දැන් මේක මෙව කරන්න තියෙන්නේ එතනදී මොකක් හරි මේ ෂිව් එකක් වෙලා නිකන් අර unexpected මොකක් හරි වුණොත් තමා මට මෙහෙම වෙන්න දෙයක් නෑ එහෙම වෙන්න දෙයක් නෑ කිසිම දෙයක් නෑ මම ක්ලාස් එක කරනවා හරි මේ මොකක් හරි වුණොත් මම ඉන්ෆෝම් කරන්නම් මේ අපි හිතන දේවල් වෙන්නේ මේක ගැලුවාම ඒ ටික හරියට උටි ෂිව් එකක් නෑ මේ දැන් පේනවනේ පොඩි කැලක් දාලා පොඩි ප්ලාස්ටික් සර්ජන් කෙනෙක් කරලා මේ රයිට් තවලන්නේ ක්ලාස් එක කොහොම හරි කරනවා මේ normal timing එක කොහොම 10 වෙනකම් කරන්න බලමු මේ ඊට තව ටිකක් අඩු වෙන්නේ මේ දැන් මගේ මේ හිටියට මේ මෙහි දැන් මොකද ෆොටෝ පෙන්නුත් බය වෙනවා කාටවත් ඇඩි ආවෙත් මේ මෙහි දැන් හැම රත් වෙලා තිබ්බේ يعني 70ත් වෙලා මෙහිම පැත්තනේ අරනේ අර ඔය මේ ෆිල්ම් වල පෙන්වන්නට ගුටි කාලා මගේ යාළුවෝ ටිකත් කිය හිටියේ මේ උඹ නම් හැප්පිලා නෙමෙයි ගහලා කියලා කද්ද මේ හොඳයි ඉතින් කමන්නේ මේ රයිට් ඒවා උලන්නේ ඒවා වැඩක් නැහැ මේ එක්සෑම් එක ලියන්න බෑ ඒ සීන් එකේ ඉන්න බෑ රයිට් මේ හරි එහෙනම් මේ ටික කරගෙන මේවා හොඳ පාඩම් දෙන්න ඔයාලත් ඉතර ගන්න ඕනේ දැන් يعني මොකෝ වුණත් මේ වැඩේ යන්න ඕනේ කියන එක තේරෙන්න ඕනේ හරි තේරෙනවනේ නිකන් අර මොන ලෙඩේ හැදුනත් දැන් يعني ඒ කැපවීම තියෙන්න ඕනේ දැන් මට නිකන් එන්න දැන් අමාරුයි ක්ලාස් එක කරන්න ඕන දැන් ළමයි ටික දැන් මෙහි ගන්නනවා ඉස්කෝල වල යනවා හරි දැන් ඒක එන්න ඕනේ ඒක කියන්නේ මටත් එන්න ඕනේ ළමයින්ටත් එන්න මම දන්නවා ටික තියෙනවා කියන්නේ මේක වීඩියෝ එක බලනුන්ටත් ඒක එන්න ඕනේ නැත්තම් අර මේක කරන්න බෑ නැත්තම් කියන්නේ ඉතින් එහෙම නැතුව මේ මලගයක් වුණා අරකක් වුණා මෙහෙ ගියා මේ අත චුට්ටක් තුවාල වුණා කක්කා ගියා එහෙම කියලා මේ බඩේ අමාරුවක් හැදුනා කියලා එහෙම බෑ ඒවා වැඩක් නැහැ කාටවත් හරි ඊට වෙන දේවල් වැඩක් නැහැ ඉතින් එහෙම තමයි ඉතින් ලෝකේ යන විදිය හරි මම පටන් ගන්න කිව්වේ ඒකයි ඉතින් කොහොම හරි මේක රේස් එකේ යන්න ඕනේ මොකක් හරි එන කවුලක් එල්ලන් හරි රෝද පුටුවෙන් හරි හරි ඒක තියෙන්න ඕනේ නැත්නම් බෑ කරන්න අමාරුයි ඉතින් මොකද හදාගෙන මේ සීන් එක හරි right එහෙනම් good night අපි නවත්වමු ක්ලාස් එක දුක හරි
Thank you sir, God bless you sir.
Very
Take
good.
care sir. Good
okay
night.
thank you bye